Hi everyone, we're still in chapter 5 to complete the sections referring to probabilities. And now we are going to talk about the product rule. So what we mean by the product rule and when we talk about product rule. Let's consider an experiment, okay, consisting of two different stages. So normally like tossing a coin, then throwing a die, then two subsequent, we say two successive events or like we say stages. Okay, so normally we have, first of all, we are interested in the result of the first event. And the first event, first of all, for the first event, normally when tossing a coin, okay, we could obtain head or tail. We know that head or tail for the coin, for tossing a coin, are equally likely. Equally likely, so the probability of getting a head is 1/2 and occurring a tail is 1/2 also. Okay. Secondly, after that, we threw a die. So we are interested. Secondly, second stage for what the second stage or the second event to obtain, for example, one of the 6 faces of a die. 1, 2, 3, 4, 5, or 5 and 6. If we obtained before the head, and if we obtain the tail, okay, we have the same outcomes. One of the 6 faces of the die. So normally we can construct and build our sample space. We can expect to have head then 1, head then 2, head then 3, head then 4, head then 5, head then 6, tail 1, tail or 2, tail and 3, tail and 4, tail and 5, and tail and 6. So normally the sample space here is consisting of like 6 plus 6. We have how many branches? We have 6 branches here and 6 branches here. We have in total 12 possible outcomes. Okay, so how in general we have independent events. For example, throwing a die isn't related. Doesn't have any relation with the die. But if we have a two, for example, we throw a die, then we throw a die, second die, it is a different things, or we will see after that. If we are talking about, especially we are talking about a box or bag with balls, okay, with replacement or without replacement. Here, everything is independent, okay, to obtain a head and a 5. How to obtain head and 5? Head 5. So we have what is the probability of obtaining, for example, this 5? The probability of obtaining this 5 is 1 from 6. So how to obtain the probability is 1/2 times 1/6. So we multiply both probability aside to obtain the number 1/12. Okay, so in general, if A and B are independent events, so the product rule is given by this formula, especially when they are independent. And we can also generalize it for more than 2 events, when all the events are given independent. So if we have and A and B, so we can replace A by multiplication, product of the probability of the obtaining A by the probability of the obtaining B. Okay. So, but we don't have the same. We have, for example, we can face dependent events. Some examples with dependent events, like if we are talking about the cards or talking about the balls, and we will see it later. So we have a jar contained 3 black discs and 2 gold discs. Okay, we have a 3 black, 2 gold discs. So we have in total 5, and each black of these three has the opportunity of occurring 1/5, 1/5, 1/5, and for each one of the gold disc, 1/5. Okay, so a coin is tossed and the disc is selected. We have a coin with head and tail where the outcomes are equal likely with 1/2 as a probability of the head, and the probability of the tail is 1/2 also. Okay, and the gold disc, because we have 2 gold discs, so the probability of obtaining 1 gold disc is 2 from the sum 2 from 5. Or the black disc, we have a 3 in total, so the black disc, it is more likely to obtain a black disc from gold disc because we have a 3 are frequent more than the gold disc in the bag, in the jar. Okay, so 3/5, 3 over the total of disc in the jar. So 3/5. So when, for example, selection of discs from the jar are totally independent from tossing the coin here. So we are talking about independent events. So we can use the product rule in this way. And we can replace it by multiplication. Probability of obtaining tail is 1/2. Gold disc 2/5. So we multiply it to obtain 1/5. And the same here, we obtain 3/10. So you can use the same strategy, but after ensuring that the two events that we are talking about are independent. So you can replace the ends by multiplication, probability of the first outcome from the first event, and the probability of the outcome given outcome from the second event. Okay, so easily solved. For example, we have a bag contains 4 green discs and 3 black discs. Okay, so normally we have in total 7. The probability of obtaining green, I think, is 4/7, and a black disc 3/7. A die is rolled. Normally, the selection of discs and rolling a die are totally different events. So normally we can use the product rule as we saw before. Okay, a die is rolled and the disc is chosen. So normally we know that the probability of obtaining each phase are equally likely equal to 1/6. Good. So we want to, for example, in part C, we want to find the probability an odd number and a green disc. We could keep in mind the probability we win with these 2 events, rolling a die and the selection of a disc from the jar or from the bag. So normally are totally independent events. So normally we can use the product rule by times. So if we find the probability of getting an odd number after rolling a die, and we know and we calculate the probability of the green disc, which is equal to 4/7. Okay, so it will be easy to multiply it to obtain the what we need. Odd number, what are the odd numbers between 1 to 6? The odd numbers are 1, 3, or 5. So normally 1, 3, and 5. So normally we have a 3, 1, 2, and 3. 3 from 6. From 3 from 6 likely equally likely outcomes from rolling a dice, and so on. So it is very easy to use these hints to calculate. So we multiply 1/2 by the probability of getting green disc 4/7. We will obtain finally 4/2/7. Okay, after simplification. And you can also complete by yourself the following exercises. We don't have any difficulty in these. Moving on to the exercise 5. Also, after ensuring that we are using, for example, we are dealing with 2 different, two independent events. The outcome of the first dice is of the dice for the first time is totally independent from any outcome if we roll it for the second time. So normally we can also use the product rule here. And we should keep in mind a number greater than 4 could be 5 or 6 only, so 2 from 6. And then even number, the even number are 2, 4, and 6, so 3 from 6. So easy to complete it by yourself. And it could be more than 2 events, could be 3 events and more. Okay, so I will let you complete by yourself the following ones. Okay, and we can remark that we can also use a convenient way of solving one of the convenient ways of solving a question is to involve the product rule and to draw a probability tree showing all the possible results at each stage. For example, we have a jar containing 7 discs, so good. Red disc, so 7 red disc from. The total is 10, so 7 of 10, we can obtain a red disk, and the probability of obtaining a blue disk is 3 over 10. Another jar, so we completed in this step, we completed the first, the outcomes of the first event. Completing from here, another jar contained 4 red and 5 blue. So in total, we have a 9. So we can obtain a red, the outcome of the second event, when selecting from the second jar, we can obtain a red or blue 4 from 9 because the red from the second jar are 4, 4 from 9, 5 from 9, 5 from 9, and so on. In these, the branches here, we have 4 branches, so we have 4 different outcomes that constitute our new sample space. We always start from the beginning, R, B, B, R, B, B. Okay, what is the probability of obtaining a red from the first event, red and red from the second event? When the 2 events are totally independent here, so normally we can use the product rule. We can multiply 7 over 10 by 4 over 9. Then we multiply 7 over 10 by 5 over 9 to obtain the probability of obtaining red from the first jar and blue from the second jar, and so on. So it is easy to calculate probability of BB. BB is 3 over 10 multiplied by 5 over 9, and so on. Same color, so when we say same color, it could be red, red, or blue, blue, so we add that both probability that we obtained before to obtain 43 over 90. Okay, so it is all about drawing a correct tree to obtain all the outcomes that constitute our new sample space. And it is easy to complete from here and using the product rule when the events are independent. Okay. So nothing is impossible here. Sometimes they talk about, for example, winning. When they say winning. So what are the chance of winning, for example? So what are the outcomes of here of this event, winning or not winning? So the symbol here, winning is W, and not winning is this tilde of W, the W tilde, or we can say W bar, or the complement of W. Okay, in each result would be win or not win, win or not win, and then we complete in the same way that what we explained before. Okay, also here it is very easy to know both hit double, for example, bullseye. So normally hit the first time and hit for the second time. Neither hits. So neither hit, not hit, not hit. And only one of them hits the bullseye. So normally one of them could be in the first event as a result of the first event, or could be in the second event. At least one. So it could be only one of them, or both hit. Okay. So you can complete it by yourself at home using what we explained before. Okay. here we have different statements with replacement and without replacement. What is the difference if we talk about with replacement and without replacement? How to use the product rule here? The product rule is very easy to multiply two probabilities of two different outcomes given occurred in two different events, for two different events or in two different stages. There are 12 novels and 9 science books. Okay, we have in total 21. Good. So the probability, 2 books are selected at random. First of all, the first book is replaced. So we have with replacement. When we talk about with replacement, so nothing differs. Nothing is different, and the whole number of books is still the same when we will proceed, when we want to select for the second time. So the first book could be a novel or could be a science from 21, because we are talking about with replacement. So we have the same number of books as novels and science for the next time, because we replaced the first book. Nothing changed. Okay, good. So also for the second time, the second book could be novel or science from 21. So nothing differs here, nothing changed. Okay, so what is the probability of obtaining novel for the first book and science for the second? Novel as first, science as second. Novel as first, 12/21. We can use here the multiplication, the product rule. Nothing prevent us to do that. Okay, and with replacement, if we obtain a novel for the first time, so the number of novels decreases for 1. So we have, for when we want to, for the second selection, we have 11 novels and 9 science books. Okay, so if we add it, we have a 20 as total in total. So we with these 20 books should be our our denominator for our new sample space. Okay, the cardinal of new sample space. So we might divide by 20. We have 11 novels, so 11/20 is the probability of obtaining a novel when we obtain a novel firstly, because we don't have to replace. We mustn't have to replace the first book. Okay, so we cancel its existence. Good. So, and if we obtain a science book in the first one, and it shouldn't be replaced. So normally the new sample space contain, or the new bag contain, or the new box contain only 8 science, 12 novel. In total, we have a 20. Okay, 20 instead of 21. Good. So the probability of obtaining for the second time science book is 8/20, and novel is 12/20 if we obtained firstly a science book. And so you can also, if you know exactly what we did here, and you realize what we did here, so it is easy to complete by yourself the following exercises. Okay, and also I give you some hints here to complete by yourself the following one. So you should know that the only idea that I want to give you in a tree, when we draw a tree, a diagram, the probability of the branches, starting from one node. Here we have a node, the branches, the sum of the probability on the branches should be equal to 1. So if this equal to 6/50, so normally this equal to 1 minus 6/50 equal to 44/50. For example, from this node, we have a 5 over 49. So normally, to complete the unit, so normally this one equal to 44 over 49. And this node, we have these two branches. So the sum equal to 1, 6 over 49. We completed by 43 over 49 to obtain the unit. These are the important idea of today. Thank you for listening and have a nice day.